Hi guys, so this is a Ream unit. This is my parents' house and they're out of AC. So I came and started troubleshooting exactly what was happening. So the first thing I did was, of course, remove the top cover, and before you do that, kill the power, So I did turn the breaker off, and once you turn the breaker off, your power should go out. Now it's safe for you to look into stuff, So I did a quick visual, and before I get into stuff, I always like to do visuals. It's sometimes things are very obvious, and you can see burn marks and things like that, So after I did my visual, I did not see anything obvious right off the bat. So then the first thing I did was turn the power on. Now, of course, once you turn the power on, you have to be extra careful, right? Because you have these two hot legs coming in. This is 120 each. That's 220 power coming in, and it's feeding this, and then which is kind of feeding this transformer, and this is a 120 to 24 or 28 watt transformer, AC transformer, and then this transformer is feeding this board, which eventually is feeding all the different circuits. Basically your thermostat is getting power from here, the outside condenser unit, so depending on the type of air conditioning you have and how you have things wired up, so then I started looking into if I'm getting, the first thing you want to look into is if you're getting the full power. Sorry guys, it's pouring down rain outside. So the first thing you want to check is the power, So I did check the power on these two terminals. Of course, it's hard for you to get your probe in there, so I checked it right over there at this connection. And I have full power, 240 coming in. So I know I'm good, both legs are hot and I'm getting power. The second thing you want to check is the input to this transformer. Now this transformer will be a little bit hot, which is normal because this is getting continuous power all the time. So I checked the voltage at the bottom, and I see full voltage coming in. So normally, you have sometimes you have a 208 feed, 220 feed, or sometimes you just have 110 feed. So depending on what type of feed you have over here, you may want to check your circuitry and see what the voltage is. So I'm getting proper power to this transformer. Now the main thing is you want to check the output, So this output should give you anywhere from 25 to 28 or 30 volt DC. So this transformer should give you from 120 to 220, 120 conversion, and then this should be, the output should be AC volts, and it should be somewhere from 25 volt AC to 30 volts, somewhere in the middle. I've seen them around 25, 28 volt AC power. This is eventually feeding your board, and so you can see this is a 24 volt board, it says right there, and this is your common. So the first thing guys want to do is put your meter right over there and check to make sure you have full 24 volt AC. As long as it's 24 volt or 30 volt AC, you're good. So that the transformer is putting out power. So this transformer is sometimes they do go bad, so that's one of the main culprits. Either you don't have power, either one of the legs are dead, or this transformer is not putting out proper voltage. So in my case, both conditions passed, so I know this was not the issue. I know the power is not an issue, so it's somewhere else. Now down the board, I notice a fuse right there. So I checked the voltage on top of the fuse, and I'm getting proper voltage on top. I'm getting about 28 volt AC power, and at the bottom I was not getting any voltage, so I couldn't really see if the fuse was blown or not. So I pulled the fuse and checked the fuse. Right now it's a 5 amp fuse, but normally they come with 3 amp fuse, and as you can see right there, it says fuse 3 amp. So it's normal for this fuse to blow on certain conditions. Now what exactly is this fuse feeding? It's feeding everything on the board, and especially it's feeding the power to your thermostat. So a lot of people, what they do is they have these smart thermostat, and then they wire the common, and they feed their thermostat from this transformer. Now remember, this transformer is meant to load up this particular circuit, so depending on the type of thermostat that you have, if it's consuming a lot of power, this transformer may not be able to hold it. So you may want to check the capacity, if this can hold the amp rating on that particular thermostat. And in some cases, if it cannot, this fuse can definitely blow. Or the second thing is, nowadays, like the thermostats, they have electronic circuits boards in there. If something shorts and something blows out, what that does is basically just fry the thermostat, or if you have a fuse, it'll burn the fuse off. So in this case, we had a bad thermostat which was causing this fuse to blow. And if your fuse does blow, definitely something is definitely wrong. Either you have a short somewhere or you have a ground somewhere that's causing these issues. The fuse, generally, it should not just blow out on its own. So if you have a condition where the fuse is blowing, then you may have another issue. So definitely don't just replace the fuse. Look for the culprit. So in my case, what I did was I undid all the wiring, the low voltage wiring, not the high voltage, but I undid all the low voltage wiring, cleaned it up, the contacts and everything, and I made sure that everything was nice and tight. The next thing I noticed on my thermostat, so let me grab my thermostat so you guys can see. So this is the thermostat that I had, and I pulled it out and I noticed it was quite warm from the back. It's not supposed to be warm. It was turning on and turning off, so I knew definitely something was not right. So that tells me that this thing is definitely going bad. So I pulled that out, and I'm just going to put a regular thermostat over there. I'm not going to put any smart thermostat right now. But at least for the night, I don't have any 3 amp fuse, so I'm going to put a 5 amp fuse. And at least that will get me off. Of course, I would definitely want to replace that with a 3 amp, because you don't want to overdo the fuse, because if something goes wrong, the fuse is not going to blow and it's going to burn your circuitry. So definitely don't want that. So this is one of the main culprits. Another thing that you may have is you may see this wire going down, and this is basically your switch, your overflow switch. So you may want to pull this out. This thing can come out, and if you see water inside, if you see any water, that means your float switch is the one that's disconnecting. So another test you can do is just pull it out, and by pulling it out, if your unit comes on, that gives you an indication that you have a blockage in your main drain line. So the other one is your main drain line that you see, and that might be blocked, which is bringing water in this thing should be dry all the time. So if you see any water in this, that tells me that something is definitely not right on this one. So make sure there's no water in this one, and the drain line is clean. Again, this particular one, the drain line, the water in the drain line should not really blow the fuse. It may turn your thermostat off. So if you see your thermostat off, that might be one of the reasons, especially if you're using a common wire from this circuit. So when I say the common wires, basically you have all these wires, that is going to your thermostat. So this is the wire, and generally the blue wire is a common wire. So this blue wire is feeding the common inside. A lot of people they just have this as a spare wire, but in this case, I'm using that as a common. So the common basically brings power to your thermostat, a smart thermostat especially, so you don't have to put batteries in them. But that's pretty much it. In my case, I found a blown fuse because it was a bad thermostat, and I'm going to change the thermostat, and that kind of fixed my issue. So I'm not going to have that problem anymore. I put the fuse in, and my AC came on when I forced it to come on. So I think that solved my issue. But if you keep having this fuse blowing on you over and over, that means you definitely want to check your circuit. Make sure no wires are loose, make sure everything is nice and clean, make sure nothing is shorting. Sometimes these wires can be touching something and shorting, so make sure there's no pinch on the wires or anything like that. You may want to go back to your thermostat and check the wiring over there, rewire it if something might be shorting. So in my case, the short is coming right from inside of that circuitry. Okay, so we know that the fuse blew, right? But there has to be a reason that the fuse blew. And I was thinking my thermostat is bad, and that is the reason. So I took this out, and since this was getting really hot and turning on and off, so I was thinking something might be wrong with this, which is pretty common, right? Things can go bad. Inside this is a lot of electronics, so that was my assumption. So guess what I did? I replaced it with another one. And when I replaced it and tried to turn the AC on, see what it did. It started to burn it off and melt this part. So of course I knew right then and there that something was wrong with the entire circuit. You know, it's just not the thermostat that's causing this. So what are the things that can really cause that damage, you know? So the only low voltage wires that are going back there is these 5 strands right there, and this has to be the reason, right? One of them is shorting for some reason, and that's causing it. So what I noticed is it really happened when I turned the AC on, right? And before that, my air handler was turning on. So before that, I had a few wires connected, you know, did not connect the outside wire. So this would run completely fine with no issues. And the way I knew it, because I didn't turn the AC on, I turned the fan to on. So on your thermostat, you will see something like this right here. So I turned the fan on just to see if the fan runs fine, and it was working completely fine, no issues. This was not melted, nothing. But as soon as I turned this to cool, that's when it started melting. So that kind of gave me a hint that the wiring associated with this is not a furnace, you know, or heat furnace or anything like that. So I don't have that orange wire that normally some of you guys may have. So in my case, like, you know, I kind of had a feeling that it's something coming from the outside unit, you know. So the outside unit has a contactor which has 2 wires. So in my case, this is the wire that is going to the outside because it only has 2 wires, and one of them is red, this guy, and the other one is white. So technically this one of them is a common wire, you know, and the other one is the yellow inside, you know. So this is the yellow wire that's going to the thermostat, the inside, and this is connected to the red wire which is going outside. So, and this green, I think it's some of them they're a sprayer. So we're only using red and white. So what I'm going to do is I'm going to undo this. You know, you can check the resistance on these 2 wires because these 2 are connected to your contactor outside. So outside there's a contactor which basically picks up from low voltage and basically provides or turn the outside air outside condenser on. So what I'm going to do is isolate these white and red wire and check the resistance on this. Okay, so I came outside, removed this, and here's the low voltage wire that is coming in. But right off the bat, what I can see is this right here. This thing is fried. The contactor is bad. It's burned really bad. So that is our culprit. And this was the whole reason for it causing that short, because the contactor is bad. And it's supposed to be nice and gold, and you can see how bad it is. Not working. So when I checked the impedance, it was way out of place. So I kind of had an idea that something is definitely not right on the outside unit. So what we can do is replace the contactor, and to replace the contactor is basically the 2 low voltage wires on the side, and then you have the high voltage at the bottom, and then same high voltage going to the fan and the compressor from the top. So we're gonna undo all this wiring, replace the contactor with another one, and that should solve our issue. Okay, so I removed the low voltage wire from both sides. So I had this brown one, and I had this blue one on one side, and then on the other side I had the 2 yellows. So I removed those, and I'm checking the impedance on this coil, and I see about 1.7 ohms. This thing is definitely fried. You can see how burned it is. So I'm just kind of curious what kind of impedance I get. So the low voltage wires are out. Now it's a matter of removing the high voltage from the bottom and the connectors, you know, these are feeding the fans and the compressor and then going to the capacitor. So I'm just gonna remove these wires. So I have the red and black one on top, and then there's this orange one that's going to the capacitor, and that's part of the common. And then I have the brown at the bottom, the black on this side, and then I have the black on this side. So just keep track of your wires. You know, I have two blacks on the bottom, so just keep track of your wires, what you're removing, how you're removing from where, so this way it's easier for you to remember when you're putting it back. And I'm gonna go ahead and remove the wires and replace the contactor. Okay, now I'm gonna check the impedance of the new coil. That sounds about right, 18 ohms. Okay guys, so I put everything back on, and I did turn it on, and works perfectly fine, you know, no issues. You know, I just turned it off so I can make the video. It was too loud. You can see the vapors right there. So it's working perfectly fine, and I'm just gonna button everything up and close this thing. Go ahead and close the inside as well, and that kind of solved my issue. So definitely, if you have a burn coil, you know, you may want to look into, you know, what caused the burn. And in my case, this is the culprit, and you're probably wondering what exactly that is. That is a wire coming from my electric company, and basically what it does, it ties into the low voltage wire, and it's kind of in series, so they can turn the power off. You know, they give you a credit for this. So this was all broken. You can see, causing issues. So I isolated this. I'm gonna have them come in and rewire this section, but as of right now, my AC is back on. I replaced the contactor, and everything is good and working. So guys, hopefully if you have this issue, this will help you resolve your problem, and it did in my case. So if you like the video, please subscribe to my channel and like the video. Thank you.